And we're live. Aikido. Espero que hayan dormido bien. Hoy andamos motivados. Vamos a repasar las que ya andamos. Ya hice una listita. En mi notion. Voy a poner starting el clock. Mira lo que tengo. Es que ya tú sabes para dónde vengo. Mira. Tengo aquí 50 interview questions que las voy a repasar y pues van a ser en total 50 practicadas. 100 practicadas porque las hago otra vez. So voy a hacer to sum. Voy a hacer consecutive gain. Que esa no estaba en Leetcode. Voy a hacer repeated in a list of buscar el number that's repeated. Jesus. Ok, y también voy a hacer sternum. Stersum. Esa, ya. Todas son de string manipulation, stir multiply. No sé si la haga. Pero pues. Vamos. Mira, si es que no están viendo la pantalla. Jesus, ¿por qué no me lo dijeron? Bueno, mi gente, vamos para encima. Pero antes de eso, escuchen esta canción. Ya. Se acabó. I have an excellent connection. Bueno, vamos para encima. Entramos al LC. LC, tu son. Ya tú sabes, baby. Este es el calendario para hoy. Vamos a programar 2 horitas. Vamos para el gimnasio. Después vamos a comer. Vamos a programar 2 horitas más. Después vamos a hacer education. Hacer unos repasos específicamente. Y vamos a organizar System to Success, que era lo que yo tengo en mi second brain, mi nuevo second brain, utilizando el PARA method. The Project Areas, Tasks, and Resources. Pues sí, mi gente, esto es lo que vamos a hacer. Va a ser un buen día, va a ser un día productivo. Y sí, vamos para encima. Creo que a la media hora, si todavía no me levantamos, voy a tomar un poquito de pre-workout. No café porque me mancharon los dientes. Fuck. Y mis frames per second están bajando y subieron otra vez. Yeah, man. I'm just shoot. Y ya, papi, Dynamic Layout. Esto está muy duro. Ya, pero yo no quiero que me voten. Copyright. Bueno, ya seteamos todo. Ahora vamos para encima. Pues yo había hecho este ejercicio como en O of 2n, O of n to the squared. It's not squared. Yeah, squared. And there's time complexity of constant space. So we could do a better solution by using a map. So how could we do it by using a map? So so given an array of integers and a target, return the indices of the two numbers such as they add up to the target. So we could put a map. Yeah, so we could put a map. Ya tú sabes. Ya tú sabes. Ya tú sabes. Ya tú sabes. Bueno. Ya había visto el código, pero vamos un poquito aquí. Infinity. No te caigas, brother, no te caigas. Jesus Christ, bro. Fuck. Oh my god, Rashid. Boy. This is epic. Vean el stream de mi amigo Justin. Shout out to him. Que hizo un epic intro diciendo que esto iba a ser un epic stream. Bueno, vamos para encima. Que es lo primero que queremos hacer if we want to do this optimized version. So we're going to. So the goal is to do a linear time, right? So linear time, time complexity, and space complexity of linear also. So being that the goals, we already know that we need to loop one time into the whole list. Or two times. The point is not squared. So we have a map. Okay, so let's say this is a list. This is a list. This is a list with values. Yeah, this is a list, right? We have a list right here. And we want to check to sum. We want to check, and there's a target. A target sum. T. Let's call that T. And this is let's call that list. Let's call this list, right? Yeah. So what can we do? Okay, so let's break this problem into different pieces. Okay, so what are the inputs? The input is a list. So the input is a list. Wait. So the input is a list, and the target, and the output is indexes of two nums. We have nums, we have target. So so yeah, we are clear what we need to process, right, in the function. So the output needs to be the index of two nums. So a way we could achieve this is by using a map and checking for the sum of so lookup time is constant space for when using a map. So let me so a really helpful function for using indexes is that we could loop. So here's the list, here's the map, right? Here's the map. Okay, here's the map. So we use the list is 1 5 9 7 4. The goal is to have 13, right? So the goal is to have 13. So and the target is, I'm just gonna write it over here. So 13. Jesus. Okay. Brother. So the target is 13. And the indexes are 0, 1, 2, 3, and 4. So 3 and 4. This is the output. So 1, we grab the indexes. So 0, 1, 0, 1, 5, 9. Wait, my bad. 5. Then it's gonna be 2, 9, 3, 7. Then it's going to be 4, 4. Then we're going to loop again. 4, 4. So 6, 7, 10. 14. So if the targets, so we have here right now, we have this number, right? So this is the index and this is the value, I and value. So the target is 19. The target is 13, right? The target is 13. So what can we do? So 13 minus the value, that is 1, is 12. So yeah, this doesn't work, right? So then we use 5. So 5. Wait. So 13. We have 12. Is there a 12 on the list? No, there is not. So we check the other one. So 13 minus 5 is equal to 8. Yeah, 8. Is there an 8 on the list? No, there is not. Is there an 8? So lookups is constant time for these, right? So it's the value, right? So if a value is 8. So there's no 8 in values, right? So it's just gonna be 13. Wait a fucking minute. So that's going to be 2. 13 minus 2, that's 11. There's no 11. 13 minus 9. And then we're going to check if 11 is 13 minus 9. 10, 11, 12, 13. That's equal to 4. And huh? 10, 9. What is the goal? Wait, what's the goal? The goal, what was it? 13? So yeah, I didn't thought of that. So the answer is, so we're going to return 2, and we're going to return 4. But we still need to check if it's in, or we could just use a fucking set. Jesus Christ. I don't know how to implement this. But I think I'm pretty sure I'm on the right track. So yeah. So we loop through each one, right? So let me do this again. So we have, so there's 1. So let's implement this solution. I first like to be sure of this. So, Jesus Christ. So we check. I don't think this is a linear time operation really. Yeah, this is not a linear time. Because if it's... So we do 13 minus 1 if is 12 on the list. So we could use another set, right? So we could do a set only for the values, right? So we could use a set for the values. Oh, that could be nice. So yeah, so we could use a set for the values, and we could simply, because if we loop through the whole fucking dictionary, that is not a linear time operation. That's again that is a squared operation. So yeah, we could use a set. So 8, and then we're going to 13 minus 1, 12. Yeah. So let's implement this solution, right? So, so what are the constants or variables that we need to complete this operation? So, what we can use is for I in range. So we need a set. So check. I'm gonna use a check, a set. So check is a set. I'm going to do index search I search. I'm just gonna do search I. So search I is going to be a dictionary. We're going to storage values for I val in nums. Search I index entry due to the value. If target and then we're going to check dot add. We're going to add the value. I need to use enumerate here. Okay. So if then we're going to do it again. So for I in nums, for j in nums, if target minus j in in check, if target minus j in check, we want to return search I, the index of j. Oh, the index of j, exactly. We don't want the value, we want the index. This is just going through the values. I'm so stupid. So, return actual search I, j, comma. So this needs to be so return search I, comma, and then we're going to return to add. So we have the index of the first one, and then check. For j in nums, if target minus j in check, we want -4. So so target minus j to potential to b sum and check. We want to return in the dictionary the index. So I think we could just switch this up. Then there would be a second sum, so it would be search Let me just quick check, because there's for I and val, so this is the index, this is the value, so search I is going to be so the target is 9. So for j nums, this operation is constant time. Let me run this. Fuck. Christ. So let's check with this test case, right? So for I, for index and value and enumerate nums. So yeah. So we have that the index value of 2, so it's going to be 0. So it's going to be is going to be 2, the index 0, then it's going to be, so that 2 is going to be added to a set to check. Then this is going to be 7, 1, 11, 2, 15, 15, 15, 15, 3, right? So we have 15, 3. Then for j and nums, again, we're going to iterate through the list. Second sum, right? So it's the number that we need to sum to. It's going to be target minus j. So if second sum, right, is in the list, we're we're going to return the search for J. We're going to return the index of J. And we're going to return the index of second sum. And the second sum is going to be, yeah. So I truly don't. So if there is not, we're going to just return empty. Don't really understand why. Let me just submit it to see how many test cases do we. Jesus Christ, so 49 out of 61 cases passed. Let me check which cases are the ones that do not pass. So 3, 2, and 4. So 0, 0. Oh yeah, that's because you can't use the same number. So we can't use the 3 again. So let me just, yeah. For J nums. So I need to find a way to not use the same character. So if 3. So we can't use the same character. So the index can't be the same. Freak. Second num, my bad. So man, shit. If second sum and check and search is not equal in the index, is not equal to the return. Let me check if this works. Shit. So it's the index. I don't fucking understand why. We already passed 41 fucking minutes. Shit. Well, 51 test cases. That's pretty good. That's a win, right? So I didn't know of this solution. So this could be a linear space complexity of a linear and time complexity of a linear. So this is a little bit more complex. I'll just check with going to be chat. What's up? Write a thank you notes to our babysitter for the last minute help. So yeah, let me just. Okay. So. Jesus Christ. I just delete this. It's almost correct. Almost correct. I can't be almost correct. I need to be correct. Shit. So your approach to some problem is almost correct, but there's a subtle issue that might cause it to fail in certain cases. The problem lies in how you handle the case where the two elements of the solution are the same number. If target is twice, so I'm not saying that there is the same number, they're the same index. Index, yeah. Jesus Christ. Let me check. Dice aquí, the problem lies in where the same number. If target is twice the value of a number in an array, like target equals 6 contains 3, and x contains 3, and 3 only appears in one numbers, your code will incorrectly return an x of 3, as if there were two different 3's in the array. This happens because your check will be true even if j and second are the same number, as long as that number is in nums. You need to modify your procedure that one is equal to a, or indeed to increase of that number in the array. So this is not a constant time operation. Second search. Is this a constant time? I don't know if it's a constant time operation. I know that for a set it is. Does this work? I don't really understand the code. I just want to check if it works. I'll just duplicate this shit. Jesus Christ. Well, 47 minutes, and thank you for watching and listening to the stream. I'm going to the bathroom and going to take a slight break. There are no views. Jesus.